All right, hello and welcome, guys. In this video, we're going to be talking about function composition. So maybe this is something that you've seen in Algebra 2. If not, that's fine. Don't worry about it. This is something that could be on the ACT and SAT, I believe. So let's get right into this. So before we actually do anything with function composition, we just want to talk about evaluating functions at specific values. So at the top, I've given you, here's the f of x and g of x that we're going to be working with throughout this video. And down the side, we can see we just have a few values that we want to evaluate. So f of 4, all we're going to be doing here is taking 4 and plugging it in for x in f of x. All right, so everywhere we see an x, we're going to plug 4 in. So that's 2 times 4 squared minus 5. And notice how I plugged in that 4 in parentheses. We're going to find that that's really important just to make sure that we are distributing and following the correct order of operations. So 2 times 4 squared, well, that's 2 times 16 minus 5. That's 32 minus 5, which is 27. All right. Now this next one, we see g of x plus 3. Again, all we're doing is we're taking this x plus 3 and we're going to plug it in wherever we originally saw an x in g of x. So g of x is 3x plus 4. So this is going to be 3 times, just take x plus 3 and plug it in. Boom. In parentheses, again, really important for distributing in order of operations. So 3 times x plus 3 plus 4. That gives us 3x plus 9 plus 4, I'll just say, is plus 13. Okay, 3x plus 9 plus 4 is just 3x plus 13. All right, then we have f of 2x minus 1. So that's going to be 2 times 2x minus 1 squared minus 5. All right, and that's 2 times, well, 2x minus 1 squared. That could be a little tough. Let's just 2x minus 1 times 2x minus 1. And then minus 5 after. That's 2 times 2x minus 1 times 2x minus 1 is 4x squared minus 2x, which is minus 4x plus 1 minus 5. That's equal to 8x squared minus 8x plus 2 minus 5, which is minus 3. So 8x squared minus 8x minus 3. All right, now for this last one. This is actually function composition for this last one. G of f of x. Well, g of f of x, we're just going to take f of x and substitute it in. Here, I'll switch over to green. We're going to take f of x, substitute it into g of x wherever we had an x. So that's the same thing as 3 times f of x plus 4. Well, what is f of x? F of x is 2x squared minus 5. So that's 3 times 2x squared minus 5 plus 4. That's 6x squared minus 15 plus 4, which is going to be a 6x squared minus 11. So that is g of f of x, 6x squared minus 11. All right, so on this next slide, again, this is now function composition. It's a function inside of a function. Okay, this is f of g of x. Another way that you guys will see this written, and I want you to be able to recognize both, is f o g of x. All right, these two things mean the exact same thing. All right, these two notations mean the exact same thing. If you see this O right here, that's not multiplication, it's not addition. Okay, that operation, you can think of it as just of. Okay, think of it as just the word of. F of g of x, which is the same way that we would read this. All right, f of g of x. So be familiar with seeing both of them. All right, f of g of x. Well, I'm going to take g of x and plug it in wherever I had an x in f of x. So that's 2 times g of x squared minus 5. And g of x is just 3x plus 4. So 2 times 3x plus 4 squared minus 5. That's 2 times, well, 3x plus 4 times 3x plus 4 minus 5. That's 2 times 9x squared plus 12x is plus 24x plus 16 minus 5. That's 18x squared plus 48x plus 32 minus 5, which is plus 27. So that is our f of g of x. All right, notice how we just substitute in g of x for every x in f of x, and then it's just a matter of simplifying using algebra to simplify the expression. All right. Now this next one, we are evaluating g of f of -2. So we're evaluating this composed function at a specific value. So you really have two options. Your first option when you get these problems is to find g of f of x and then just plug in -2. Or you can find f of -2 first, and then whatever that value is, plug it into g. So that's the method that I'm going to do here. That's probably my preferred method. So let's start off just by finding f of -2. That's going to be 2 times -2 squared minus 5. All right, that's 2 times 4, which is 8, minus 5. That gives me 3. So now f of -2 I know is equal to 3. So I can just take this 3 and substitute it in here for f of -2, because f of -2 is 3. All right. So now we're just going to find, well, then what's g of 3? G of 3 is 3 times 3 plus 4. That's 9 plus 4, which is 13. So g of f of -2 is equal to 13. Now we have two more examples that I'm going to show you guys. These are not function composition. All right, these are just kind of different operations that we can perform on two functions. So for this one, we're given f of x and g of x, and we want to find what's 2f minus 3g of x. So now this looks confusing, but really all this is just 2 times f of x minus 3 times g of x. So just plug in f of x and g of x and then simplify. All right, and I'm not going to show out all this simplifying. You guys are strong enough in algebra that you don't need me to show you how to distribute and then combine like terms. All right, so you just simplify that down. Now this last example is again a combination of two functions, but it's evaluated at a specific value. All right, so we're evaluating it at -4. That's what that -4 afterwards is saying. So this is the same thing as 3 times f of -4 minus 2 times g of -4. All right, so my recommendation would be, well, start off by finding what is f of -4. If I were to plug in -4, I get 2 times 16 minus 5. That's going to be 27. So f of -4 is 27. And then g of -4, that's a -12 plus 4, which is -8. And now I'll just plug those two values in. So it's 3 times 27 minus 2 times a -8. 3 times 27, that's 81. And then plus 16, well, 81 plus 16, that is equal to a 97. All right, so that is 3f minus 2g of -4. Hope this helps you guys out for the classwork that you will be doing today.